On this week's MetPy Monday, we'll wrap up talking about file paths by looking at some best practices, things that we've seen people do that are not so great and make your code not so portable, and some ways to get around that. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. On this week's MetPy Monday, I'm going to be talking a little bit more about paths and sort of wrapping up our whole path discussion that we've had the last couple weeks. A lot of times, I've seen scripts that scientists are using to work on some data, and it has something like this at the top. My data is /user /your username /some project /data /raw. And that works great on their system, but it's not the best practice for a few reasons. The first is it is very specific to your system. If you share the script with someone else and they want to rerun your analyses, they have to go and change this path in every one of those scripts unless their username happens to be J. Lehman and their file directory structure is exactly like yours. And that might not even work because between operating systems, the paths will need to be represented differently. So for example, this would not work well on a Windows system. And then also it's an absolute path, which absolute paths always scare me a little bit. Generally, you want to get into the project directory or wherever you are for the sort of the home of your data and your analyses, and then move up and down from there so that you can move that directory easily. Let's say I sign up for Dropbox and need to move that data to Dropbox. Now I have to go and change it to user J. Lehman Dropbox project data raw everywhere, versus if I just had data raw and said that this needs to be started from the project directory, it doesn't matter where it is. So there are advantages and disadvantages to all of this. A few of the solutions: using a relative path, like I just mentioned, using a library like pathlib to get around some of the operating system specific things, and creating a variable somewhere at the top of your notebook that is the home path. So if you do have to change it for any reason, it's right there, and you just have to change it in one place, not have this same string for your path copied 20 different places in your notebook, and then you have to change them all and run it and realize you forgot to change one and go back and change it and run it again. It's just not best practice. It's not maintainable. So let's say that I am going to work with that same file structure I had last week. So I've got a data folder and a scripts folder here. So I'm going to go ahead and import the path object from pathlib. And I'm going to create a path to my current working directory, which is wherever I launched the notebooks from. I'm going to create a data path, which is data, and a script path, so notice these are relative paths to my current working directory. If we wanted to see what the absolute path was, as we've seen before, we can use .absolute. So in this case, you see, I actually am in Dropbox, and I'm on a Mac, which is a Unix-based system, so I have this POSIX path to my Dropbox file where I'm working. So now let's look a bit more at what we've got in here. If I go to Data, Project 1, there's some notes, run1 and run2.txt. So let's say that we need to do some analyses. In this case, the analyses is going to be to print it out. But let's say we need to do some analyses on those run1, run2 files. Maybe there are a couple runs of a model. So don't do this. This is what I see a lot of times, though. So run files run one.txt, run two.txt. Then we loop for fname in run files. We open data project1 plus fname in read mode. Sometimes I will even see people put the full path there, so it could be this. We're going to print f.readlines. So this is where we're doing the work. We're calling some calculation function. We're making a plot, something like that. And then we close our file. So this works. The file run1.txt has the line, this is some important data, and the file run2.txt has the line, this is some more important data. But notice I broke a lot of those rules that we talked about. I have system-specific absolute paths that are operating system dependent here. So this path will only work on this specific computer that I'm on right now unless I get another one and has the same file operating system structure, and I put everything in the same place. So we can make that a little bit better by removing the absolute part, but it's still going to be operating system specific. So a better way to do this is with pathlib and a couple of other little tricks. So this is the much better way. First of all, I don't like that I have hard-coded run1, run2. We can see what those file names are programmatically, and then if I add run3, run4, run5, I don't have to remember to go back and update that list of files. It's just going to automatically go over everything that's there. So again, I'm going to go ahead and redefine data path just so that we reinforce how this might be done in your script. So path object to my current working directory, then data, then project1. This is for that specific project. For fname in data path dot glob star.txt. With is a context manager, so I'm going to say with open fname read as f, print f.readlines. And again, this is where we're doing the work. And notice there's no f.close. So there are a few things going on here. First of all, the context manager opens that file name in read mode as f, the file object f. And then when we're done using it, that context manager automatically closes it for us, so I don't have to remember to type f.close. So that's nice. Then we go back up to the loop. Now we're doing everything that ends in .txt. So let's go back and look in our directory, and that's not going to work because we have this notes.txt. I don't want to make a graph or do analyses or statistics on my notes. It'd probably crash whatever my script is. I just want to do it on things that are run something.txt. So we'll change our expression here to be run any character.txt. So now it should only work on those two files. So we run this, and we see we get the exact same output, but it's a lot easier to read. And it's one line less because we don't have f.close, and it's more versatile because we are not hard coding those file names. So it will work on any operating system as long as the notebook is launched from the base directory where there's data and project under it. This will work. It will work on an arbitrary number of files, and it uses nice, clean programming concepts like context managers. So I hope this helps you improve the way that you deal with files on your system in a programmatic way, and it'll certainly save you a lot of time. Thank you for joining me, and I'll see you on next week's MetPy Monday.